This is Algebra 2 lesson 2-5, using linear models. We're going to talk today mostly about scatter plots. A scatter plot is a graph that relates two sets of data by plotting the data as ordered pairs. For example, it might be comparing age to income. It might be comparing miles driven to cost to run the car. A correlation is the strength of the relationship in a scatter plot. And that correlation is normally determined by what we call a line of best fit, sometimes referred to as a trend line, that gives the most accurate model of the related data. The correlation coefficient is indicated by the strength of the correlation. It's identified by the variable r. If your r value is close to 1 or -1, then that means it's a fairly strong trend line. The more closely the data resembles a line, and the more accurately your model is likely to be. It will be determined by your r. If your r is 0.962, that's a fairly strong data point, and that means that your trend line is very accurate. But if your r value is 0.324, that's not a very good correlation, and then it's not going to be very accurate. Now, sometimes it's possible to model data in real-world situations, the linear equation. You can then use that equation to draw a conclusion about the situation. Now, in a scatter plot, the closer the data points fall along the line, the stronger the relationship, and the stronger the positive or negative correlation between the variables. In this first example here, you see that this is a positive correlation. The data points fall close to a line with a positive slope. And if I was to draw a trend line in there just by hand, my trend line would be similar to this, because you want to get as many points as you can on the line with as many points above the line and below the line as possible. A negative correlation, the data points fall close to the line with a negative slope. The positive correlation has a positive slope. This one has a negative slope. My negative correlation here is a little bit stronger than my positive correlation. Okay, my negative correlation would be a very strong negative correlation. The last graph here shows no correlation because I really couldn't draw a trend line. It kind of looks like somebody sneezed on the page instead of giving you points that were in some sort of an array where you could definitely tell whether the slope is positive or negative. Now, we're going to create a scatter plot, and then we're going to use that scatter plot to make predictions. Below here, I have listed the percent of people 25 years or older with at least a bachelor's degree, which means they went to college and got a bachelor's degree, 4 years of college. And the median, which means middle, household income for 12 states in the year 2000. Percents are rounded to the nearest whole percent, incomes are rounded to the nearest thousands of dollars. We're going to describe the correlation between the percentage of adults with a college degree and their median income. All right, so here is our lovely table. Okay. We've got Arkansas, Alaska, California, Florida, Mississippi, Montana, North Dakota, North Nevada, Texas, Washington, and West Virginia. So, adults with at least a BS or BA, that's one value, and the income is the other value. We're going to use this as our X value, and this is our Y value right here. So, I'm going to first label my graph. So this would be degree, okay, BS degree or a BA degree. Okay. And I'm going to have to give this a little more space here, because I also need to be able to write on my scale. And then the other one is going to be my income in dollars. Okay. You want to make your scales as good as you can. I noticed that the lowest percentage I seem to have seems to be 15%. The highest percentage I seem to have seems to be about 28%. So I don't need to go much past 30. So if I decide to do my percentages, 2, 4, 6, 8, 10, 12, 13, 16, 18, 20, 22, 24, 26, 28, 30. My lowest value for money seems to be 30. My highest value seems to be 52. Okay. So I'm going to do by 5,000s, 5,000, 10,000. Okay, I'm going to actually put this thousands of dollars. So I only have to label. This would be 10,000, 15,000, 20, 25, 30, 35, 40, 45, 50, 55, 60. There we go. So I'm just going to now just plot these points as, exactly as we see them, as coordinate pairs. So 25% and 52,000. So 25 and 52, 25, about here. And then 1934, 1934, about there, that's too high, but we're going to go 27, 47, 27, 27, about there, 22, 39, 22 and 39, 17 and 31, 24 and 33, 22 and 35, 27 and 43, 27 and 43, 18 and 45, 23, 40, 40, 28, 46, 28, 46, and 15 and 30. So if I was to look at all those dots right there, I could say that it looks like the slope is going up, but it's not a strong positive slope. So this would be a weak positive correlation, what we can determine from this graph here as a weak positive correlation. If I wanted to make a prediction, I could draw myself a trend line, and then I could make a prediction off of that. For example, I could say, okay, what's the median income going to be for somebody for a percentage of people who have 30% have a degree, and then I can determine that. But that's how you make a scatter plot. Now, the next thing we need to be able to do is use that scatter plot to make a, to write an equation for a trend line. Okay, so here we go. The table below shows the median home prices in New Jersey. What is an equation of a trend line that models a relationship between time and home prices? Use that equation to take the median home prices. All right. So we start with 1940, go all the way to 2000, and there are house prices going up rapidly. So the first thing I'm going to do is I don't want to have to graph from 0 to 1940. So I'm going to let 0 is going to equal 1940. Okay, so 0 is going to be equal to 1940. So from there, I can just go by 1940, 1950, 1960. So let's say we have this. So I'm just going to take it up and down a little bit. So if I'm going to decide to do this, this is 1940, this is 1945, this is 1950, this is 10 years, 1955, 1960, 65, 70, 75, 80, etc. There we go. This would be number of years since 1940. So 1940 would be 0 years. 10 years from 1940 means this is 1950. Okay. And then we're going to do the median home price, thousands of dollars. So I'm going to scroll that back here. The median home price. $47,000. Okay? So let's say 10 to 20,000, 40,000, 60,000, 80,000, 100,000, 20,000, 40,000, 60, 80, I'm going to say something here, ground, or 80, and then obviously 100, and blew off my graph. Okay, so let's graph these points now. So 1940, it would be 0. Remember, this is going to be 0. This will be 10. This will be 20. This will be 30. This will be 40. This will be 50. And this will be 60. That helps you graph it along the line. So at 1940 was 47,100. So approximately there. 1950, it was 63,000. So about there. 1960, 76,000, almost 77,000. There. 1970 is 89,000, almost 90,000. Oh, I messed up here. I just see that. 60, 80. I messed up right around here. So this is 80. 100. 120. 40. 60 is here. I know I don't have my 207 on there, but I can extrapolate my graph to there. All right, so where were we? We have 1940, 1950, 1960. What's 1970, which is 30, 90,000. 30 and 90,000. And then we're going to do 40 and almost 120,000. 40 and 20,000. And then 50, I'm going to skip that one for now. And 60 is 175. 60 is 170. Split up here a little bit. $170,000. Good. Okay. So we do have an outlier. This would be considered to be an outlier because it's way outside of everything else. Okay. And that's okay. You can have outliers. They don't necessarily have to land anything. Okay. If I was to draw a trend line here, I would try to get as many points above and below the line as possible. So I'm going to draw my trend line in a different color so that you can see how we got red. So if I was to draw my trend line, it's going to hit quite a few of these points. So I'm going to say probably let's do this. I'm going to black. Get rid of this black one there. Okay. Might adjust my trend line just a little bit here. Close. Down this way. There we have the trend line. That's fairly accurate. Let's just put that. And now remember, it's not going to be perfect because you're doing it, not a computer. So there's my trend line. If I want to, says to write the equation of the trend line, and you're like, ooh, how do I do that? Well, you try to find 2 points that are really close to the trend line. I like to pick the first and last point if possible, because the first and last points normally are fairly accurate toward what the trend line is. So it really doesn't matter. You can pick any 2 points that look like they're fairly close to the line. And on my particular graph here, it looks like Like 1940 is a reasonable, not 1940, excuse me. Well, 1980. Maybe this point here and this point here look like they're pretty close to where my trend line is. So if I choose those 2 points there, okay, I have 10, 63,100. And then I have, in my case here, I have 40, 119,200. Now, if you draw your trend line a little bit differently, you might choose 2 different points, which means your equation is going to be slightly different than somebody else's. So you have to be careful with that. Don't expect your trend line to be exactly the same as somebody else's, unless you're doing it on a computer program. All right, so let's figure out the slope of these lines. Let's do that first. Okay. So I was going to do the slope of these lines. I'm going to do 63,100 minus 119,200 over 10 minus 40. Let's subtract those really quick. 63,100 minus 119,200. And give me negative 56,100. Okay. If I divide that out, I'm going to get a positive 1,870 over 1. So, my slope is 1,870. So if I wanted to do my equation, of this line, my slope is 1870. I'm going to pick a point. I think I like to choose the smaller points because it's easier. So I'm going to say y minus 63,100 equals 1870, parentheses x minus 10. So if I was to finish this, y minus 63,100 equals 1870x minus 18,700. Add 63,100 to that. We're going to get y equals 1,870x. Plus 44,400. So that would be the equation of my trend line. Okay, and like I said, your trend lines might be different if you chose different points. So there's the equation of my trend line. Now we're going to use this equation to predict the median home price in 2020. Okay. Price in 2020. Well, remember, x equals 0 is 1940, so take 2020, subtract 1940, okay, and that tells us that's 80 years. So x equals 80. Okay. So y will equal 1,870 times 80 plus 44,400. So we're just going to evaluate this now. So plug this into your calculator. Take 1870, multiply it by 80, and then add 44,400. You're going to end up with y will equal $194,000 for the median home price. Remember, not the highest home price, but the median home price. Now, looking at this average price for 2020, it seems a little low, which means our trend line could be a bit off. So that's the problem with using a scatter plot and trying to figure out your trend line, is if you're not really accurate, you could have a bad prediction. And sometimes that happens. All right. Finding the line of best fit. Now, you research the cost of movie tickets for recent years and look at the trends. The table shows your data. What is the equation for the line of best fit, and how accurate is your line of best class. Based on your linear model, how much would you expect the paper movie to get? 5. This is a calculator problem, which means you actually have to use your calculator to figure it out. So, essentially what I'm going to do is I'm going to walk you through this here, and then I'll walk you through it again in class, just in case you can't follow what I'm doing. I'm going to do this on the TI-84 Plus. For people who have the TI Inspire, I will show you how to do that in class. So, first thing I'm going to do, I'm again going to let 1995 equals, or 1994 equal year 0. There's 1994 is going to equal year 0. So, basically, then this is going to be 1, 4.35. This will be 2, 4.59. 3, 5.06. 4, 5.65. 5, 6. Oops. I'm going by 2 years, aren't I? I messed that up. Let's start over again. I haven't paid attention to my years. Right? 1995 is 1 year from 1994, so that would be 4.45. 1997 from 1994 is 3 years, so that's 3, 4.59. And then we're going to go 99 is 5, 5.06, and 7, 5.65, and then 9, 6.03, and then 11, 6.41, and finally 13, 6.88. Now, I give you those points because those points happen to correspond to what we call L1 and L2 in the stats column of your calculator. So you're going to turn your calculator on, and you're going to find the stat button. It's a big black button that says STAT. And then you're going to push that button, and it's going to have an edit. It's going to be highlighted. Actually enter that. If you have anything listed in lists 1, 2, or 3, that's what L stands for, list 1, list 2, list 3. Highlight the L1, hit clear, and then hit enter. Highlight the L2, which means you're going to navigate to L2 by going over and up. Hit clear, and then hit enter. And then you're going to just enter your data. So in list 1, I'm going to go 1, enter 3, enter 5, enter 7, enter 9, then 11, and then 13. What you're going to do is enter those like they are a table in an Excel spreadsheet. In L2, 4.35, enter that. 4.59, enter 5.06, enter 5.65, enter 6.03, enter 6.41, enter 6.88. Now we've entered all of those data points. Okay. The next thing you need to do on your calculator, once you've entered all those in your calculator, then you need to go to your stat again, so it's the stat button. So now you're going to calculate. Okay, you're going to calculate. So instead of edit, go over 1 to the calculate. So you're going to get the calculate, C-A-L-C. And then you're going to go to 4, which is linear regression. It's going to say L-I-N-R-E-G. And it's going to have an AX plus B. You're going to hit that button on your calculator, so you can go down to that. And then it's going to bring back the home screen, and you're just going to hit enter. And you should get a nice little equation here. It's going to say linear regression, L-I-N-R-E-G, and it's going to give you y equals ax plus b, and it's going to tell you a equals 0.2178571429, and it's going to say b equals 4.0421485.7, and then you should have an R factor underneath that. You should have an R, and that's going to equal approximately 0.9969, okay, which essentially means we can now find the equation, because that gives us all the information we need for our equation. So our equation is going to be y equals 0.2178571429x plus 4.042142857. Now, nobody ever wants to carry that many digits in their calculator, so you can round. I normally round about 4 flat digits. So for me, I would probably round this to y equals 0.21786x plus 4.0421. Okay? So since my R factor is really, really close to 1, that's a very high R factor, so my line of best fit is very accurate. And the next thing we do, this is part A of our equation. That's what it first asks us. It asks us, A, what is your equation for line of best fit and how accurate is it? It's very accurate, and that's your equation. Part B says, based upon your linear model, how much would you expect to pay for a movie ticket for 2025? So for part B, 2025, okay, 2025 minus 1994, because remember 1994 was year 0, is 31 years. So we're going to put 31 in for x. So we're going to have y equals 0.21786 times 31 plus 4.04214. So I'm going to put that in my calculator right now. So if I put that in, 0.21786 times 31 plus 4.04214, I'm going to get 10.7958. So I would expect to pay approximately $10.80 for a movie ticket in 2025. So as you can clearly see, these calculators make it very, very nice for you to be a lot more accurate. Because I'm pretty sure if I put in L1 and L2 for my equation for my trend line for the original problem that we just did, I would have a much better equation than the 2 points that I chose to work with my trend line. Which shows you that when you have a calculator and you can use that technology can make you a lot more accurate.